The answer would be actually simply the duties to be drawn and to be to be framed very easily, no more no less, because an expert actually, let's say, an digital forensics specialist would be able to draw his duties based on what? Based on his expertise, and the expertise actually, what is it? What he has to do, the duties, no more no less. So the benefits or the impact or the consequences, certificates would influence, or let's say draw, would actually give as an extra as an added value to the digital forensic expert, is to help him draw clearly and specifically his duties, what he has to do, what he would be able to do, no more no less. Disciplines are a question of certificates, because none from the non let's say qualified parties would be actually questioned or required to do investigations for a sensitive case if he is not already qualified. So those sensitivities, they are a question of certificates. To say that I am eligible for that, you have to prove, and the proof is the certificate, no more, no less. Let's talk about the unit number 4, which is data acquisition now. Here we are going to draw the ways, in addition to the tools, the technologies responsible for, for help and digital forensics usually acquire data, which is the knowledge, the enumeration. Actually, first of all, the if I define the word enumeration, it is one of the very pillars, very big pillars, and very actually, let's say, um, most stressful pillar in the cybersecurity cursus. It is one of the very primordial, initial, primitive steps that cybersecurity specialists has to go behind in order to investigate incidents and to check, to make, let's say, exploitations and vulnerabilities scans and so on, like that. So the enumeration. It is here seen as data acquisition. It's purposely dedicated to a specific environment, a specific case, a specific scenario, and so on. But at the end of the day, the data acquisition, it is a context of enumeration. So it is data gathering. Acquisition, you acquire data. You need data. Here, it is a context of gathering as much as knowledge related to a case, a circumstance, a crime, a digital crime, and so on, whatever. But one of the differences when we compare this data acquisition versus the enumeration we know in the cybersecurity is that in cybersecurity we might return 0 when we finish the enumeration phase. We might return with 0 knowledge. We might return with 0 knowledge, and we have to continue. Cybersecurity expert has to continue to next phases. He does not stop there. In the sense of, with 0 results, we have returned with no value. Let's say no fruitful value after the enumeration. Yes, we can do that. Actually, we can reach that level. At the same time, he has to continue with the phase 2, phase 3, and so on. Whether he has to try to inject or what, try to pass to the social engineering scans or whatever in the cybersecurity. Yes, he will not stop if he had no results. But here, no. Here, no. In the case of the digital forensics, in the context of the investigations behind the forensics, as an expert, if you return with 0, no, you cannot pass. It is not only you cannot, and you do not have to pass to the next phase. After acquiring data, if you found 0 results, you do not have the right, as an expert, as a specialist digital forensics, you do not have the right to do next steps, to pass to the next step, single, or to the next phases, next steps in plural. You do not have the right, and you cannot even if you want. It's not, for example, you want a trick and you want to finish your job and you want to just do next phase, and you'll say later on I will redo another scan and another enumeration phase, another data acquisition phase. No, you cannot actually. You'll fail. You'll fall into a step of failure. Why? Why is this here? We are completely seeing the difference. Is that here we have the digital forensics expert has to have a valid value after the data acquisition, otherwise he will fail in next phases. Uh, the case is actually it's not forbidden. There are no doors to open after final values behind the data acquisition. No, but questions would have answers. Investigation, it's a long process. Starts from, we define chapter number 1 that this investigation has to start from recognizing that there is a digital crime. And the final step is to answer all the questions. Amongst of them is to terminate the bluer view of the case. Means all the questions has to be answered. What happened, who did, when, and what are the circumstances, and so on. All the questions have to be answered. This is the final step. If the acquisition, which is the first step to acquire knowledge of what are the limits, the borders, the frontiers, involved parties, if you do not have the answer of those questions, you cannot pass to the next step. Absolutely. So without the answer of the trivial initial primitive questions, next phase will not be actually answered. Means if we pass to, for example, chapter number 3, we were talking about the lab and the office of the digital forensics expert, how it has to be, how it has to look like, and what are the equipment that has to form the lab and the the lab and the office. You'll not be able to set. So here I took those 2, 3, 4 minutes just in stressing on this context of data acquisition, just to stress on that this data acquisition is one of the very primitive, yes, phases in the investigation process. Absolutely, after settle in the lab, yes, maybe, and it is one of the very required to be terminated perfectly in order to continue a successful investigation, a successful forensics process. So, okay. This unit is tackling absolutely the data acquisition, how it will be happening. This how we are going to talk about the data required. What is the shape of the data we will go beyond in order to say that yes, we acquired data, we finished the acquisition of this of the data required. And then in addition to that, we are going to see the respective methodologies. Let's say methodologies how to do and what are the tools to use. This is the main objective. We are going to see some of the techniques that they are actually standardized. The redundant array inexpensive disk. It is one of the very famous actually scenarios that data might be actually but we investigators can go beyond in order to retrieve data and to understand the scenario and to understand what happened and so on. So we see the standardized methodologies, and we see actually the famous and the available tools in the market. Tools for what? For investigation only and for data acquisition. Yes. First part. Data acquisition means actually can we actually go beyond acquiring data in a Microsoft Word file? Here we have to say that yes or no. There have to be actually evidences for that. So the format of the data to acquire. Starting with the medias we use to store data actually means whenever we are dealing with a digital context, so there have to be actually memory to store the evidences and the memory where a crime has happened, both of them, they are storage devices, hardware, and they are running using using software, the file system, or whatever the architecture is used to manage that hardware. So we have to recognize clearly the architecture of the storage device in order to succeed in finishing our investigation. So first phase.
دكتور
Yes.
شوية صوتك خفيف.
Are you able to hear me better now? هل في الصوت أفضل؟ Is it أفضل؟
أيوة.
Yeah, this is the mic. I'm sorry. So the format of the storage device, it's one of the questions because now we are presenting for example, we are presenting now PPT. Actually, it's an on cloud service, and I'm using a Microsoft operating system. The disk is stored in the operating system, which is a Microsoft, and the architecture that this disk is following is Microsoft based, absolutely, and it can be standardized for different operating systems, yes, but this is an architecture that we have to recognize. This is what we talk the storage format. It is the file system managing the storage device, something like that. Let's dig in. We are going to remember that the main concern here in this phase, in this scenario, is to understand the storage equipment hardware, how it is controlling the data inside, because a flash disk or a hard disk or any let's say compact disk or whatever, it is storing data because of an architecture controlling the data inside. For example, I say that I have a flash disk, a USB drive that has a capacity of 8 gigabytes, or I have another one now that has a capacity of 128 gigabytes. What does it mean? Both of them, they are having two different file systems that we have to understand completely. Otherwise, we will not be able to investigate. We will not be able to acquire the data from inside. If there is a crime happened using that pen drive, if we do not understand the architecture, how it is stored, we will not be able to acquire data. So technically here speaking, I take the same example here. Two pen drives. One is with 8 gigabytes, and another one is with 128 gigabytes. 8 gigabytes, it's a good space for a pen drive. It's a good space. Yeah, it can be enough for saving a lot of data. But 128 is much more bigger when we compare it with the 8 gigabytes. The file system controlling both is different. The first one, you can use the FAT32 or even the FAT16 as a file system. Let me write it for you, just for your reference only. File system, I was saying here, we might use for the let's say for the 8 GBs pen drive, we might use actually the FAT16 or the 32, whatever. Let's say for 32 simply. FAT32 as the system file, the file allocation table. File allocation table is the system file that can be utilized to manage the pen drive, the flash disk that has the capacity of 8 gigabytes. But for the 128 GBs actually pen drive, no, it is not enough. Actually, 100% it will be enough. It will be actually successful. But for such commercialized pen drive, we might use the exFAT, let's say 32, extended FAT32. Here, in this regard here, we will use the extended file allocation table format, which is another file system architecture that can be utilized for large pen drives. What is this, and why we are talking about that, and what is the relationship with the digital forensics? Okay, let's take the example of this here. Let me change the color also. Good. Here, yeah, what's the purpose behind? The purpose is that storing 8 gigabytes using this file system, it will help the computer follow an architecture that is completely controlled by this mechanism. A file system means a mechanism, it's a dedicated mechanism. Using a different file system means using a different mechanism, how the data is spread inside the device, the storage device. If we do not know the file system, we will fail in extracting the appropriate data from the storage drive. At the end, acquisition has failed. Acquisition has failed. So in conclusion here, the storage formats is one of the questions that we have to storage formats is one of the questions that we have to recognize in order to succeed in the data acquisition phase. We talk about formats here. The stress is on this word. The stress is on the format word. No more, no less. So I close. I everything. Great. Let me change the color even. No worries. Great. So we may talk about actually there are types here. We'll talk about the static and the live in the sense of we are going to use um, a fixed. Let's say it's a static. Then there will be no alteration. Absolutely, there will be no alteration in the data acquired. So like it is, copy paste. It's a matter of a copy paste. No more, no less. So we are going to use a static copy of the available, let's say, resources in question. This is standardized. This is a standardized approach. Means we are going to use, for example, if it is FAT32, the FAT32 is a very famous file system adopted with a long list of storage devices. Okay, we can adopt the same mechanism to acquire data. For all the FAT32 storage devices, FAT32 based storage device. So yeah, referring to a static acquisition. The same scenario will be applied. Full stop. Since the standardized architecture is yes standardized and adopted with all. But if we talk about, for example, running, let's say not the flash disk here, not the pen drive, not the storage device, the hard disk. We talk about the RAM. We talk about a volatile memory, a random access memory like RAM. Yeah, what should we do? The same system? No, because the data is volatile. The RAM is volatile. It's something that actually can be available only during runtime. And if you run anything new, it will delete what has been already stored inside the RAM. If you run anything on top of the volatile memory, it will delete what has been already available actually earlier. So this is another context. So either we talk about static acquisition or we talk about live acquisition. Static is something actually stored already, and we're going to follow standardized process to reach the data inside. Live, we are going to maybe we may refer to another standardized approach. Yes, absolutely true. But we will actually take the consideration of the data that it is volatile. What does it mean volatile? Volatile means to be utilized in runtime, live. Now you use it, now available. You closed, has been disappeared. The problem is not here. because if you close it, it is not visual to you as a user, but in the memory it is still available. The problem comes is that if you open something else, then only it will be disappeared, it will be vanished, because what you open, it will be opened on top of the same memory, so it will delete old data. This is the problematic view. This is what it makes it much more sensitive, much more, let's say, yes, to be taken with much more precautions than live acquisition. It is one of the scenarios that the investigation has to go beyond. It is one of the places where the data acquisition might happen also, might happen in. Cloning a disk. One of the scenarios actually to solve the issues of the live data is to make a clone of the storage device. In the sense of what does mean cloning? Either we are going to make a copy or we are going to make an image, something like that. So you are going to make a copy paste, something like that. Yes, or we are going to make a full picture, or a full, let's say, yes, I use the word picture, yes, because we are going to refer to a technology that generates another copy, but 100% similar and with the same status, with errors, with let's say logs, with the real data, with the file system, everything from the original media content, a hard disk, a flash disk, or whatever. The original content, there will be another image from that. Here, image or picture, it's not a photo, no, but it's exactly another copy, but with the same architecture. It's a copy paste, yes, but it's with the same architecture. What does it mean? Means the same data will be put, the same file system will be put, the same errors will be put, the same logs will be put, and so on. And more than that, it is with the same architecture, with the same locations, with the same order, with the same numbers, sectors numbers, clusters numbers, and so on. This is said a clone. So bitstream image, it is another bitstream copy. It's to make a copy from the storage device content, but with the same architecture. It is sort of a cloning, and the cloning is a mirror, like in the sense of mirror. Yeah, this is the copy, and the other one is similar to the first one. But here the mirror, it's another. Let's say there is an inertia point where we can do a copy, but the image or the cloning does not need an inertia, because clone might be done remotely, not in the same framework. We can make a clone from a pen disk, a pen drive, into a hard disk. We might make actually a clone from a hard disk to a server, a file server, or something like that, the cloning. But the mirroring, no. The mirror, it is to generate an object into another object with the same even physical architecture, hard disk to hard disk, a pen drive to a pen drive, a server, file server to a file server, let's say architecture, something like that. So the mirror is something, even physical architecture has to be copied. I repeat, approaches to help us to acquire data from storage devices. Still, we are talking about the format. We might refer to a copy from the storage device, simple copy, yes, like the word says. But there are approaches. We are not going to make a right-click copy paste. It's not like that, but it is a sort of a copy. Yes, what we find inside, we have to use the appropriate approach to open the data and copy it. Bitstream copy. Or we are going to make an image which is a clone. Clone means actually we are going to completely take the cloning to clone, or cloning to clone, or cloning. The content in the sense of we're going to take the data and the storage device architecture with the same order, with the same let's say content. Even the errors and the logs they will be actually copied also. So we are making an image, or we are cloning the storage device. With this respect, which is the architecture also, we are generating a bitstream image. Otherwise, if you do not respect, we take all the data without respecting the order, without respecting the format, it is just an image of the storage device. If we are making the same image, but also we are respecting the architectural, the physical architecture, the physical, let's say, environment, we are making a mirror. Here an image is the full content, and the full content actually it is the memory, and the memory it is segregated into sectors, into clusters, and the cluster is segregated into sectors. The storage device usually when we talk, mainly when we talk about digital storage device, we talk about list of clusters, and the clusters they are subdivided into list of sectors, and every one sector holds a data. Every one sector holds a data. Really, the data is might be a portion of an image, a portion of an audio, a portion of a text, or something like that. So instead of making a full drive, let's say a storage device image, we might go beyond a sector-based copy. The sector, so it is the smallest unit to store data in a storage device. The smallest unit in a storage device used to store data. Sector, yeah. Where to put the data inside the storage device? A flash disk or a CD disk, let's say compact disk. Where? It is the data is spread inside the storage device. How it is spread? Because the data, it is not to be put like a bulk, an image, copy paste a full image. No, it is to be spread in two packets, let's say, and every packet in a sector. Full stop. Something like that. At the end of the day, we are dealing with data in a storage device. So here, they are 100% correlated. Means if you just have a look from the sector copy, when you compare it with a stream, let's say bitstream copy, 100%. Without the sector copy, you cannot make a bitstream copy. Without sector copy, you cannot make a bitstream image. Without sector copy, you cannot make an image, a full image, regardless of the order. Without sector copy, you cannot make a mirror of the storage device. So they are 100% related, all of them. All of them, they are correlated and related. Any questions, Aya?
No, Mr.
Okay, I'll stop at this level. This morning, stop with the recording.